This is a video for Module 1, Problem 14, and here we're given a probability histogram that represents the number of live births by a mother who is 50 to 53 years old, and they had a live birth in 2012, okay? So here they're asking us different probabilities, and the key is that you want to go ahead and take a look at the numbers that are at the top of each bar. So even though they've kind of given you the bar, which we know we can follow across to find that probability here, they've given you the actual probability right on top of the bar, which is extremely helpful so that you don't have to estimate at all. The other thing you want to remember is that if they're talking about things like the word or in probability, fourth or fifth would mean that I'm going to add those two probabilities together. In the first one, letter A, we don't have to worry about adding anything. It just says, what is the probability that this randomly selected 50 to 53-year-old mother who had a live birth in 2012 has had her fourth live birth? So I say, okay, she's had her fourth child, her fourth live birth. So that probability is going to be 0.112, and I just type that there. Now in letter B, this one, they want to know what the probability is that she had her fourth or fifth live birth. So because it's fourth or fifth, I'm going to take a look at the fourth, which is 0.112, the fifth, which is 0.105. I will add those probabilities together, and that will get me 0.217. Okay? Now in letter C, they're saying sixth or more live birth. So the probability of having her sixth or more. So we say, okay, what's the probability she had her sixth? More would be her seventh or her eighth. So we're going to add all three of these together. 0.031 plus 0.035 plus 0.049. And that will get us the 0.115, so about 11.5%. And the last one, it said if a 50 to 53-year-old mother who had a live birth in 2012 is randomly selected, how many live births would you expect the mother to have had? Now, this one, it might look a little bit complicated, but I just want to show you how they kind of explain it here because I think it's nice to see. I wish that I could write on my screen, but currently that feature is not working for me, so sometimes it helps to bring up the view and example so I can actually show you and explain the work here. Makes it a little bit easier than me just saying it. Okay, so here we are. Okay, so here they're giving us a little bit of a different probability distribution, but that's okay. They're saying to find this value, recall that expected value of a discrete random variable is the mean average of the discrete random variable. The mean of a discrete random variable is given by this formula. Now I know that sometimes statistics can have its own little language, it has its own symbols, and these can be a little bit scary. But let me explain what this means. This mu sub x just means the mean of the variable x equals, okay, so this is just the mean of that variable, and in this case it's the mean of the variable x, which is the mother between this and this age in 2012. This big E is big sigma in Greek, okay, it's a Greek letter, and it just means take the sum, so it means add up all the values. Then what you do is you say, okay, before I add up all the values, what I'm going to do is I'm going to take every x, every value, and I'm going to multiply, sorry about the plane, it's a little bit loud, by its probability of x, p of x. So I'm going to take every x and I'm going to multiply it by its probability. So what does that mean? It means that we're going to take every value, 1 child, 2 children, 3 children, 4 children, 5 children, and so on. We're going to multiply them by their values, their probability values. So 1 had a probability of 0.238, so I'm going to multiply those together. 2 had a probability of 0.284. I'm going to multiply those together. 3 had a probability of 0.176. I'm going to multiply those together, and so on. And I'm going to add all of those together. Okay, so that's all that formula means. And you can probably see now while I wanted to show you how to do that. Again, I wish I could write on my screen right now, but it's just not working, okay? So in this case, they did want us to round to 1 decimal place, so they're just using the little approximate symbol. So it's approximately 2.9, okay? So what we're gonna do in our problem, the numbers are a tiny bit different, but it's not a big deal. You're gonna do 1 times 0.236 plus 2 times 0.263 plus 3 times 0.169 plus, and so on and so on and so forth. And once you add all those together, you'll round to the 10th place, the first decimal place, and that will get you 3.1. So I hope that that helps. And it really is much easier than it looks at first. Again, stats can be a little bit scary. So if you ever have any questions about any of that notation, just let me know.